So good morning. This is day 11. We're on day 11 of writing a TCP/IP chat application. It's been a great journey. I think today might be the last day that I'm actually in the code. We will see. But good morning, everyone. Well, it's morning where I am, anyway. Good afternoon and evening to the people who like to watch in Europe. And yeah, if you have any questions or any comments along the way, feel free to just drop it in the chat. I will try to keep an eye on it today. And let's jump in. I want to talk a bit first about where we are in terms of different levels of abstraction. I know I've walked through that a couple times already, but I want to walk through it again today because we're adding to that level today. We have a working TCP/IP application. I can now use the word working correctly because it's actually a correct implementation. We finished off our keep alives yesterday, so now we actually have a proper TCP/IP application as of episode 10. So today I want to add in, right now it's just all our messages are just, I'm sending this message, we send this other broadcast message, there's no replies to any of our messages, but a command reply or like a poll response, command response, those kinds of patterns are very, very common in TCP/IP applications. And so I want to add one of those and kind of show how we can structure that API in the code. And I've actually never done this because the ways to do this that we currently have with the task-based asynchronous pattern and TaskCompletionSource and all of that didn't exist when I was writing my old TCP/IP applications. But I have like an idea in my head of how I want it to work, so we'll see how well that goes. As usual, this is live coding, so I may make mistakes and we may, we'll see what happens. All right, so let me switch over. Good morning, Michael. All right, so so an overview of where we're at now. What we have is we're using the socket API directly. And then I have this pipeline socket type, and this takes the socket API and really kind of exposes it as a system IO pipelines kind of pipeline API. So we've got a pipe reader and a pipe writer coming off of this type. And logically, this is very similar to network stream. Okay, so if you have, so you can write, or you can create a network stream just wrapping a socket, very similar to this. Network stream takes the socket API and exposes it as a stream API. This type takes the socket API and exposes it as like a pipeline API. And I'm writing directly to the socket, in and out of the socket, using socket reads and writes. You could actually say if you didn't want, to go quite this low level, you could do something like use TCP client, for example, which has a network stream off of it, and then you can actually create a pipeline off of that. So you could actually like have your network stream wrapping the socket, and then wrap that with a pipeline. There are methods that support that. I think they're hanging right off of pipe writer. So pipewriter.create will actually create like a pipe writer API around an existing stream. So this could be a network stream. And then there's a pipe reader.create. And I think you can call both pipe reader.create and pipe writer.create on the same stream. I think. I haven't actually ever tried that, but that's what you would have to do if you wanted to wrap, say, an existing TCP client, right? If that's what's currently in your code and you wanted pipelines. The reason I want pipelines is not for the efficiency, right? This is quite efficient, but I actually don't want pipelines for the efficiency. The reason I want pipelines is to make my parsing code much easier. So the next level up is our chat connection, and this is where we take the pipelines and we convert this to a stream of messages, right? So I'm using channels, system threading channels, to represent like a stream of messages. So instead of a stream of bytes coming to and from the pipeline, we have a stream of messages. And so all the parsing code, actually most of the parsing code has been removed from this chat connection type and moved into this message serialization type. And this code is very clean because we're dealing with a pipelines API. Or actually buffers over here by the time it gets over to here. Chat connection takes the pipeline, and all the buffer management and all that stuff lives in this type. And then our message serialization just has to deal with serializing in and out of buffers. So that's why it's very clean. Okay, so the type that I'm not going to add another type. I could, add like another layer and say, this is my actual client chat connection or whatever, TCP, essentially, TCP client chat connection. I'm not going to do that. I think I'm just going to keep this chat connection type. But what I want to do is add something a little higher level onto this type. But before we go there, I'm going to go ahead and write down what I'm going to do, because I've talked about this a couple times already, and I'm just going to write it down. I want to have a SetNickname command, and then the server, going from client to server, and then I want the server to respond with, yes or no. So it's ACK or NACK. This is a very common pattern. In fact, I'm going to structure this. You'll see this a lot in different TCP protocols where the ACK and NACK are like shared between different commands. So I'm going to, we'll go ahead and do that. So I'm going to say my type 3 is going to be a SetNickname command. And this is from client to server. The payload has one field. We're going to have a short string, and this is going to be, we'll call it nickname. Used as the so we're going to say like to be stored. Well, okay. So this is going to be a short string. What does it actually mean? Identifying the current client. The server should respond with an ACK or NACK. So this is acknowledgement or no acknowledgement, which means no. It doesn't mean a missing acknowledgement. It means I'm saying no. All right, so we also need an ACK or NACK here. So I'm going to say type 4 is going to be my ACK. Right now we only have commands going one direction. But I'm going to say this is bidirectional, just to allow, if we wanted to send commands from server to client, then the client could actually ACK or NACK. And these are going to be shared types, right? So we've got type 5 NACK. So the idea is if we add other commands to this protocol, then the responses to those commands could just be this style of command. And that helps prevent situations like, well, I've got my SetNickname command, and then I've got an ACK nickname or NACK nickname command, and then I've got some other command, and then I've got an ACK and a NACK for that kind of command. It just helps keep the number of types of messages down. Another common pattern that you'll see is these. Sometimes an ACK message does have to carry a response, like a response data. We don't have to do that in this case, so I'm not going to address that. But these are just things you have to think about when you're developing a protocol. Another common pattern is to have like a command response type, and then have a field in that command response be the actual ACK or NACK, yes or no, succeed or failed. That's what ACK and NACK means, is success or failure. But I'm just going to keep it as separate types for no real reason. It's just an arbitrary decision. And let's see. So because they are separate types, these don't actually need any fields. So I'm just going to copy this. So I've got an ACK and a NACK. All right. So that's, I think that's, oh, and of course our versioning. We have to bump our version, let's say 0.5, and, okay, I'm just gonna add in here, add SetNickname, ACK and NACK. All right. I'm just gonna say in here like what the server semantics should be. If this, oops, if the server responds with an ACK, then all future broadcast messages from this client should use the nickname as the from field. This is just kind of like setting expectations of here's how the chat server should behave. All right. I think that is all we need for the actual protocol. So I've defined a type 3, 4, and 5, adding several more message types here. And at this point, you might want to split out these this whole iMessage, chat message, broadcast message, keep alive message, and the 3 new message types into maybe a subfolder here. And I'm going to go ahead and do that. Because again, this is a common pattern that you'll see in these kinds of libraries. Here's this library that implements this API. They'll have like a messages folder or whatever. So we will take our existing ones, shove them in there, and clean up our namespace. I don't know why it's not suggesting that. Just do it by hand, that's fine. And then we'll get some builders because we're looking in the wrong space for these. So let's finish this cleanup here. Come on. Okay, there. Now we're all using the proper messages and sub namespace there. All right, so let's just go ahead and close all that. So what we want now is we're going to now add our 3 new message types. We've got a SetNickname command. So this is going to be now I'm using command here, so I really should use like response here. ACK response and NACK response. I think that helps make it a little clearer. I like, some people use command response, or request response is another very common one. Like if you look at HTTP client, for example, uses request response. That's some common terminology. Let's change to that. I'm going to do that. Set nickname request. So I think people are going to be a little more familiar with request response than command response. All right, so now we can call this message, or we can just call it request. And I don't know what I'm gonna do, we'll see. So we've got a broadcast message with a from field. I'm just gonna copy this thing and say, wherever hits the road, I have to choose a name. So it's gonna be set nickname for sure. We want a set nickname message or set nickname request. I'm gonna say request, or both. Request message, there. We're just going to be super explicit here. This is the set nickname request message. And in this case, we only have one field, which is going to be the nickname. And this is going to be the nickname. All right, yeah. No, I don't know why you would think I want native overlapped. I do not want native overlapped. There. All right, so we're going to set that nickname, pretty easy. And then we've got a couple of empty messages. So we have one existing empty message, so I'm just going to copy that. And this is going to be a Now this isn't just a SetNickname response, this is just like a general ACK response. ACK response message. And also a NAC response message. Save that first. So. All right, that should build. We're good. Okay, so we've defined our new message types. Now we have to go into our serialization layer and say, here's how you actually parse them and convert them to and from bytes. So we've got we have to get the message length, and again, so this is something that I'm leaving as is, but I do want to call out, it seems kind of like a code smell, but what I've chosen to do with this project is to have these message types just be plain old data types. They don't actually do anything, these are records really, that these should probably be records as far as our actual type system goes. They're just defining the structure of the messages, and that's all. They don't do anything with converting to and from bytes. I've got that in this message serialization type, but the disadvantage is we've got this if, else if, and this is getting longer and longer as we add more message types. And we've got one up here for determining the length of the message, and then we've got another one, so we've got our message length, and then we've got another one for, wherever it is, down here. So we've got one when we're actually writing the message. We go through that if, else, if, checking types over and over, just finding all of our derived types. And this is when the actual bytes are written out. So this is converting a message to bytes. We're doing this if, else, if in two different places now. And this is a pretty good flag that, hey, this should actually be a member on your iMessage type. And normally that would be true. I'm not going to do that. So the idea is, you would have like this, you would add a member to iMessage saying, how long is this message, right? And then each implementation would implement that with, here's how long, here's how many bytes this data is, my messages. And then you'd have one that took like, where are we at in our span writer here. So then you would have another method that took a span writer and says, write yourself out to this span writer. So that is entirely doable, and it looks like something we really want to do. The problem is we also have another if, else if in our serialization code. It's on the reading side, and this is where it gets a lot more awkward. So normally you've got that if, else if checking the types. Well, that's clearly an indication with object-oriented design that belongs on the iMessage type. The reason I'm not going to do that is because of this other if, else if, which is here when we're reading. Okay, so now we've got this message type, which is an integer, an unsigned, well, I guess I don't specify if it's signed or not, but it's an 32-bit integer, big endian that we've read from the stream, and now I need to take this message type and convert that into a message object. And that's what this code does. So I've got this other if, else if in here. And what this does, this is a lot harder to convert into an object-oriented design, because now I want to call one method like on a base type, right? So on this iMessage type, and you can have methods on interfaces now, which is kind of weird. But I mean, like methods with implementations. So what I really want is like a static method on the interface that derived classes would be able to like register with. I'm handling this message type for this thing, and then that one master method would walk through the registrations and say, okay, so then delegate it to this specific implementation. It just ends up being really, really messy because we're trying to we're treating our hierarchy like inverted, right? I don't know the right name for this problem, but this is why I'm leaving this code as is, because we can elegantly solve the one if, else if problem. The other one becomes a huge mess if you try to solve it elegantly. So I'm just leaving it as is. So our serialization code has these 3 else if blocks that we have to update each time we add a new message. And that's just my decision. You can write your own code how you want. So let's see. So we've got our, we need to determine the length of our ACK and NACK, which is actually going to be the same as our keep alive because they're all empty messages. So I'm just going to say or message is actually, I think I can say or ACK response message, right? Yeah, I like that. So I don't have to repeat the message is part here. So so it's checking for any of those 3 empty messages, and it's just the message type length. That's the only thing that gets sent with those messages. The other thing is our actual set nickname request message. And in that case, we have, I'm going to move this up above these empty ones, just so the empty ones are second to last here. In this case, we have a short string. I'm kind of thinking I'm going to like extract this out. Yeah, I'm going to do that. So before I do this, I'm going to refactor these so that they're just a little bit cleaner and a little bit more obviously correct. So I'm going to define a local method here and say, what have we got here? Let's say that this is a I want to say is a short string field length. This is going to take a value for the field. And this is going to be the short string length prefix length plus however many bytes are in this value when it's UTF-8 encoded. I'm just going to bring this up so you guys can sure to see that. Yes, I like that. And I'm going to do the same thing for my long string. So this will be the long string length, prefix length, plus the actual byte count for that value. All right, so using these helper methods in our chat message then just becomes, instead of doing this addition here, I'm going to say that this is my long string field length of the chat message.text, since that is encoded as a long string. And then my broadcast becomes our message type length plus the short, so we've got the short string field length of the that was not useful, broadcast message.from, and then the long string field length of broadcast message.text. Yes. So that just, just kind of cleaning up this code just a little bit, making it more obviously correct. Okay, so now when we have this set nickname request message, it's just going to be message type length, again for the message type, and then a single short string field. So a short string field length of, I need the actual value here, set nickname request message dot nickname, which we're going to encode as a short field. Okay, so that handles our message length. Now let's handle actually writing it down here. I'm going to skip over this other one temporarily. This other if else if, we're going to skip over the reading and do the other writing. All right, so I need to add in, this is not fantastic, but it works. I'm going to add in the ACK messages. This is going to be the right message type of, 4. 4 is our ACK message. our NAC message, our NAC response message is going to be 5, 5. All right, oops, that didn't work. 5, there we go. All right, and then I'm going to add in one more, non-empty message. So I'm going to stick it up here. Message is, what did I call it? Our SetNickname request message. All right, so now we've got a message type of 3, and then I'm going to write a short string with the actual requested nickname. All right, that looks good. So now we are properly writing out our SetNickname request, our ACKs, and our NACKs. Now let's read them in. Okay, so we've got a message type of 0, 1. Let's go ahead with 2 is our keep alive. We don't want that one in here. But if, oops, message type is 3, then we're going to try to read this short string, which is going to be our field of the nickname. And if that works, then we're going to new up our, I keep forgetting what I called it, the SetNickname request message. Thank you. And return true. And we also want, we also want to do our other empty messages. We are ignoring our keep alive messages, so they fall through to here. But we don't want to ignore our ACK and NACK, even though they're empty. So I'm just going to say else if message type is equal to 4, then there's nothing else to read, so we're just going to new up this, that's the ACK, right? Got to make sure I do the right one. All right, the ACK is 4. And return true. And then we have message type of 5. The message is a NACK message, NACK response message. All right, that's looking good. Let's compile this. We're not actually using these messages yet in our apps, but we should be serializing them in and out at this point. Okay. No questions in the chat yet? All right. So let's start using these. I'm gonna need like a separate UI for that. So let's go ahead and do that first. It's very clear that no one hires me to do UI design. All right. So I'm going to want, is it a text box? Let's get those two mixed up. Text box and text block are just too closely defined, or too close to each other. All right, so this is going to be my nickname. Is there a way that I can do so I don't want text in here to begin with, but I don't know if there's a way to do, what's it called? Where you have like a placeholder. We got a placeholder? Doesn't look like it. Yeah, fine. All right, I'll just use a label. Labels are supposed to be better anyway, right? Okay, I don't know where that went. There. Yeah. So this is going to be the nickname. And of course I've got all I haven't bothered to set all the proper things set up here. Close enough. And then I'm going to create a button over here that just says set. Right? So this is going to be for this box. Close enough. And this is going to be set. Okay, so the idea is we can connect, send messages, and we can set our nickname to whatever's in this box. And I guess we can just toss in some, oops. Set my nickname to Bob by default or whatever. All right, so still got our log window down here, and I'm just keeping all the incoming chat messages in the log window. I'm not going to make like a separate window for that. Or actually, let's do that. Let's go ahead and do that. I'm going to take this text block here, and all right, I think, yeah, that worked. All right. This will be my chat messages over here. And this is getting a little full. Yes. This will scroll, right? I think it'll scroll automatically. All right, I think these both will. Okay. So this one I'm going to start putting my chat messages in. Instead of log copy, this is going to be the actual chat. Okay, so now on my chat client, I want to start using these and say, okay, so when I am reading the messages, so I'm processing the socket here, when we get a chat message, I actually don't want it to go in the log, I want it to go into the chat. All right, and then the other thing I wanted to change, we need to actually do our, so we're handling the broadcast message. I also want to handle, oops, there's an F in there. ACK responses. And this is where it's getting a little bit, okay. I'm just gonna log this right now. Of course, that's what I forgot. Silly me. Okay. I'll fix that in a minute here. Okay, so we've got the ACKs and NACKs are just going to go in the log right now. And then I'm going to have this nickname. Better name this box too. So this text box is going to be my nickname. All right, so now I can say, whenever they click this button, I want to, I'm going to do something similar to sending a message. Although, what I really want to do, okay, so ignore it if there's no connection. Then we're going to do the set nickname request message with whatever's in the nickname text box. My naming is all over the place here. I apologize for that. So we've got the, so I'm going to send out a nickname request. Now, okay. So I'll come back and clean that up a little bit later. Except I do want to, I gotta change this. Sorry, this name is completely wrong. I'm just going to call this the nickname text box. Can't let that go. All right. So now we can actually send that nickname request, and we're just, any ACKs and NACKs, I'm just gonna log. All right. I did forget one thing in the protocol, which is what I realized when I was writing this code. But I will circle back around to that after we get the basic stuff working. So let's go over to our server now. When we process our sockets, we are going to, So it handles the chat messages. The other thing it has to handle is the nickname requests. All right, so at this point we are going to actually extend our connection collection. And this is something that's very, very common in TCP IP servers. So Freddie, message identifier. Yes, that is what I forgot. Thank you. In my protocol. I will circle back to that. Freddie knows what he's doing. All right, so in this connection collection, we currently are just keeping a list of chat connections, and now we actually want to start storing some state with that. And this is very, very common on the server side, is to have some kind of structure that is going to include your connection to the client, whatever that type is. Here it's chat connection or TCP client or whatever, and then also has some other state information with it. So in this case, I want to start keeping our nicknames, right? So we're going to keep track of each client's nickname, and if one client asks for a nickname that another client already has, you can't get it, right? It's already claimed. So that's where the NAC comes in. So let's go ahead and say, I'm trying to think of how I want this API exactly to look. What we actually want is like our own kind of a client chat connection type. So I'm just going to add a separate type for that. It's going to be a client chat connection. And this is definitely going to have a chat connection, right? Which is actually like, the actual connection. So I'm just going to call this chat connection get. We're going to initialize this with a chat connection. That worked. All right. So we've got this chat connection, and then I also want a nickname. So this is going to be a public nickname. This can be null, so when they first connect, it's not going to have anything. I'm just going to say get and set for that, because I think I'm going to move all the management of this keep all the management of this in the connection collection type, and this will just be like, here's the data that I'm tracking for each client connection. I think that looks good. All right. So this client chat connection is now what this is actually a collection of. So this becomes that. When we read it, it can be any of these. So we've got an add. When they add the chat connection, I want to create a new, server-side state for this connection. So this goes in here. And then this becomes, if we're removing something, this chat connection is disconnected or had an error or something, so I want to get rid of it. Then in that case, I'm going to remove, I think remove all is what I want, because it's a list type, right? Yeah, so I can just stick in this. So we find whichever connection, whichever of our state objects has that connection, and remove it. All right. The other thing that we want to do is, because this one has the lock, it's controlling this this collection. We want all of our nickname updates to also flow through here. So I'm just going to go ahead and do this, just because I know we're going to want it. So this will be a Boolean try set nickname. So we've got the chat connection that wants to set its nickname, and we've got the nickname that it wants. So what we're going to do is we're going to lock this, and if I'm just going to do it, simple, not exactly the most effective or efficient, but whatever. If any of these have a nickname that matches, then no. We're just going to say no. And this even includes, even if it's the same connection, no, you can't have your own nickname, it's already claimed. I don't care. You know, you can handle the corner cases however you want. But if that is not, you know, so if there's any that already have that nickname, just return false. I'm just going to say it's an ACK. And then I'm going to say, well, I guess, yeah, fine. I guess we can like, okay, I'm going to change that already. Again, live coding, this is me changing my mind 5 times in the half hour that I'm doing it. Let's say, so let's say here's our client chat connection. This is going to be connections dot, so I'm looking for, you know, this actual state, okay? And then if this is actually null, then that means we've actually just disconnected. So I'm just gonna, it doesn't actually even matter what we return. Otherwise, if we already have that nickname, this is just slightly better semantics, right? Then I'm gonna say, fine, you can have that nickname, even though you already have it, okay. And then we're going to check to see if anyone else has that nickname, then we return false. Otherwise, I'm going to set the client chat connection nickname to that value and return true. All right. Not, you know, not terrible. Okay. This is a fair amount of work to be doing in a lock, but it's fine. Okay. So we've got our try set nickname, which then can set a nickname for a specific chat connection. So let's jump back to our server application that is actually processing these messages. Okay, yeah, because I changed this to a client. So we need the x.chat connection, or actually just, we can just say, there. So now we're treating this like a collection of chat collections in here. Chat connections in here. There's way too many similar sounding words. All right. So that does the chat message. Now let's handle, I'm just going to handle the set nickname here. I'm not going to handle ACK and NACK because right now those are only going from server to client. So if we have a set nickname request message from a specific, oh, we can't use the same name there. If we have a set nickname request message from this chat connection, you know, it would be nice if we had like a TypeScript style. If this is this, then, you know, in here we can actually treat it like that. I don't know how hard that would be to do on a language level. Anyway, just random thoughts. All right, then let's go ahead and let's do the console.writeLine. We've got a nickname request message. And this is going to be the nickname. And then we want to say, what's our connections? Connections dot try set nickname. And we're going to pass in our current connection, which I don't know what variable it is. Chat connection. Okay. So we've got a current connection, which is our chat connection, and our its requested nickname is nickname request message dot nickname. All right. Now we just need to send our ACK or NACK back based on this. So if it is, if it's true, then we can send back an ACK. So send a message async, say a new ACK message, ACK response message, yes. Otherwise, to, yes, send a NACK message. All right. I think that would work. Let's see if that's going to work. As Freddie pointed out, I am missing message identifiers, which is very, very important if you're sharing ACK and NACK responses. So I'm going to talk about that and fix that also. So this is like technically working, but not something I would ever publish. All right, I didn't open all this up this morning. Beg your pardon. Just gotta find where this is. I'm one of those people who has endless projects going all the time, so it's hard to find stuff sometimes. Okay, so here we are. Let's jump into our server. It built fine, so let's see how well it works. Jump into my chat client too. So we can do a connect. We can send data, works fine. I'm gonna try setting my nickname to Bob. It says it got the nickname request and it's set to Bob. All right, got the ACK. Let's just kick off another client here. Because if we set it again from here, it's gonna say, it's gonna ACK again because we already have that nickname. But if we connect another client and it tries to get the nickname, the same nickname, got a nickname request message from this other one named Bob, and then the second one got a NACK. Okay, so our ACKs and NACKs, our logic is working correctly there. There is one other thing that's not working. If we send a message here, that did not get over here, which is interesting. So if I send the message over here, it's not getting over here. Okay, so I broke something there. Let's take a look at that first. Okay, so I broke something with this, this chat message here. So it got a got the chat message. Creates a broadcast message. And then we are selecting all the chat connections. That should be working. It's in the other text box. Thank you, Freddie. Okay. I just want to... Oh, man. I forgot I did that. Boy, live chat is saving me today. Okay, so if I connect here and I connect here and I set my nickname, I set my nickname, get a NACK, send a message. Yes, so it shows up in the other text box now. I didn't even see that. Boy, am I tired. All right. So there's one other thing. So that code is working. It's not broken. There's one other thing that I wanted to fix is that this over here should actually be the nickname Bob instead of this IP address. And that's a pretty simple fix. I'm not actually properly using it yet. When we're setting this from field, what I want to do is say, okay, so what I actually want to do is be able to look up my current connection. So I want to say like, this might end up being a little bit ugly. Current connections. Okay, so I'm just going to say like, here's this connection. And this is going to be like this instance of the server state for my thing. And you know what, actually, because this is always going to be the same, I'm going to return that from this add method instead. So because we're creating this new instance of the server state in here, I'm going to say, here's my add. And pull this out so we can return it. Oops. That'll be cleaner. And I'm overloading connection here. Yeah, I am overloading connection. This is my client connection, which is actually my server state object. So then I can say my, I'm going to use client connection again here. Again, not the best naming. I apologize. But then I've got this. Now I've got, so in my processing loop, I've got, here's my like underlying chat connection, and I've also got, this is the connection with like the server state with it. The one thing you want to be careful of is when you're doing this set nickname request, you don't want to just set the nickname property on that state. You want to go through, because a nickname request has to check whether everything else has that nickname, this has to go through like that collection type. So we have to call this try set nickname instead of just setting the nickname. Okay, so I don't need this connection because I have it now. I've got the client connection. So this is going to be my client connection dot nickname, or remote endpoint toString. This would work, I think. The reason I hesitate is because that nickname is being set under lock. Yeah, but actually it's always going to be set by this method. Yeah, so there's no danger of reading an out of date value there. Okay, so that's fine. A lot of times threading can get a little bit tricky when you're dealing with server-side collections of state for all the different client objects or client connections. All right, so that should work. Michael says, is it possible to implement something like response message equals client.send command request message? Right now, request response is sent and received in different places. Yes, Michael, that is exactly what I'm planning to do today. Although we're already getting close to end of time here. I might go a little long today. But that is exactly what I wanted to demonstrate today. We're just not quite there yet. All right, so now we should be able to be using that connection, or using that nickname. So we can connect both of these right away. The first ones get sent with whatever your IP address is. We can set our nicknames. One gets an ACK, the other one gets a NACK. The one that gets an ACK is now called Bob in the chat. That works. The one that got a NACK is still using its IP address. Okay, so that is exactly the expected behavior. We've got it all working. Excellent. Now, as Michael pointed out, what we really want is to have a nicer API here. I'm going to go ahead and check in this code. I don't usually do like midday check-ins, but where are we at? Day 11. Set nickname. But before I do that, I have to fix what Freddie pointed out. Yeah, this is taking a lot longer than I thought. Before I do that, I have to fix in the protocol something that I totally forgot. So anytime you have like this kind of request and response idea, ideally what you really want is to have a message identifier or a command identifier, right? Or a request identifier, really, not a message identifier. A request or command identifier, and then the response, the ACK or NACK, will include that identifier. So like this is the ACK or the NACK for that identifier. Right now, our protocol has like this implicit state, right? So if the client sends a nickname, then it expects the next ACK or NACK to refer to really be an ACK or NACK for that nickname request. And you really want to avoid that kind of implicit state if you can. So I want to use message identifiers here instead of assuming that the next response would be ACK or NACK, or assuming that the next ACK or NACK response is for the last request I sent. And the reason for this is it allows you to send multiple commands, right? So I can send a nickname request, and then I can send a something else request without having to wait for that ACK or NACK first. So state can definitely be annoying. If you look at the history of different protocols, you can see people moving away from that. So HTTP is a perfect example. It started off as, here's my request, and then the server sends the response. And that's all you can do. In the original HTTP, you couldn't even reuse a socket. And then they extended that so that, yeah, you can keep alive your socket and send another request, but still your requests and responses are all one at a time. If you're requesting something that takes a while, well, that socket has to wait, right? You can open up other connections, but you can't do any other requests over that same socket. And then, so if you look at HTTP 3, built on Quick, then now we definitely have like multiple requests in flight. That becomes possible over a single connection, and that's not using TCP. I know, so it's kind of cheating, but there's no reason we can't do that in TCP world. Another example is SQL. So all of the SQL protocols that I'm aware of, like the client sends a like a query, right? And then the server responds with the data. The problem is there's no identifier in that on the wire protocol, so there's no way to send, okay, do this query and then also do this query. No, you have to actually have like a separate connection for that. And sometimes you'll see an error if you're using, at least Entity Framework surfaces this. I think any .NET database client would surface this, where you get that that error. Oh, it's a really common error. I'm gonna look it up just to see, because I can't remember what it's called right now. SQL multiple queries, single connection. My Google Foo's not working here today. And what's that exception message? Because there's an exception message that shows up that are always. I can't seem to find it. All right, I'm not going to spend time on it. But essentially, there's this error message that is very, very common with people trying to do multiple requests, especially asynchronously, right, on a single database connection, because the protocol just doesn't support it. That's what it really comes down to, is the protocol doesn't support it. So you can only have one request at a time, and it's just annoying, right? It gets into people's way. There's no reason why we can't. So don't design your protocols like this, like I did today, because I totally forgot. So always have your requests and your response include some kind of an identifier. So we're going to add, I'm going to say request ID, and that's what I'm going to call it. And I really want this to be a GUID. GUIDs are really nice because they're unique. You don't have to think about it. So sometimes you'll see it's an incrementing integer or something like that, and then that always gets awkward if you're trying to reconnect. And anyway, when that counter gets reset and the other side isn't expecting it to get reset, it can be a pain. So just use GUIDs. That's what I like to do. All right. So now these are no longer empty messages. So now we have identifying the request this response is for. All right. So I'm going to go ahead and push on through. If you guys have to get going, I understand. I've got some extra time today, it being Saturday. So I'm just going to go ahead and implement this, and then I'm going to try to get to that point where we're adding that next level of abstraction for our requests and responses. That's my goal for today. Don't know if we'll make it at this point. Okay, so I've updated the protocol. My ACK response is now going to take a single field of a GUID, and this is going to be the request ID, is what I'm calling it. Okay, all right, thank you. And then same thing for our NAC. SetNickname request message also is going to need a GUID, and I'm just going to pass it in, just like all of our other things. I'm not going to create it automatically, not here. So let's do that. We've got a GUID for a request ID now. And now all our code is broken. We have to go back to our serialization. We have to decide how to serialize GUIDs. Oh, right. Also in our protocol, I defined GUID, but I didn't actually say how it's actually encoded. So let's define a type for a GUID. I'm kind of thinking I might actually just want a short string. A lot of times on the wire, GUIDs are actually represented as strings, but in this case I'm just going to say, because GUIDs are big endian by default, I believe. So if you call like GUID.getBytes or whatever it is, I think it is big endian. So I'm just going to say endian. Well, actually, I'm just going to say because GUIDs do have a defined byte order. So I'm just going to say, how many bytes is it? Is it 16? 16 is 128 bits. So that's, is that 32? I don't know. Okay, how big is a good GUID? 16 bytes, yes, all right. A 16-byte binary value. And that'll be it. All right. I capitalize it here, so I'm just going to capitalize it there. And that should be sufficient for our protocol. All right, so I'm going to take, when we are talking about message length, the nickname request is now also going to be the size of a GUID. So I'm just going to create this GUID length, which is just going to be, I'm just going to hard code it as 16. So we've got our SetNickname request is now also going to include the GUID field. I'm going to break this out just so that it's clear. These are different fields. Our ACK and NACK also now have, data. So this just becomes keep alive. Our ACK or NACK are the same size, so I'm just going to keep them in the same if branch here. And this is going to be the message type length plus the GUID length. Okay. So now we've handled our message length. Let's handle writing them out. One thing that I do want to add in here is our GUID, right? We want a way to write a GUID. I don't know if this is going to be in primary primitives. Anything for GUIDs? No, I don't see anything. I think it's all just integers, doubles, floats. Looks like all integers and float types. That's fine. All right. So there is a 2-byte array. That's it. Returns a 16-element byte array that contains the value of this instance. So I'm just going to write this out as a byte array. There might be a more efficient way to do this, but I'm not worried about micro benchmarking right now. And then we're going to, oh, I have a write byte array, don't I? So I'm just going to say write byte array of those bytes. That's all we need. All right, that's nice, pretty simple. So now I have the ability to write a GUID to my stream, and I'm going to use that with the SetNickname. I'm going to write the GUID now of the request ID. And then for keep alives are still empty, so I'm going to move this down here. Our ACKs and NACKs now have a GUID as well. Oops, so I actually have to read that out of the messages. We've got an ACK response message .request ID, and then a NACK response message. With the request ID. Okay. So now we're writing correctly. Let's go fix where we're reading, which is where Visual Studio is telling us we're wrong. All right, so before we read the nickname, we're going to have, I want to try read GUID, which we don't have yet. Okay, so let's write that. Stick it over here. All right, so here we've got our bytes. So we can use the same kind of pattern here. I'm just going to copy this. I'm going to try to read a GUID. And we're returning a GUID, or out value is a GUID, I should say. And all we're going to do here is, this is just like reading reading a string in bytes, except that our length is fixed, so we have a GUID length. And so we try to read that, and then we advance, right, because try copy 2 doesn't advance the position. Really what I should do is like make this into a try read byte array, maybe. And that way that copy paste, it exists in 3 places now, will go away. So I'll do that in a minute. And then we're going to say, we're going to new up a GUID from the bytes, which I think, yeah, that's what we want. All right. And that's it. Okay. I'm going to go ahead and do this real quickly, just to factor this out. So this is going to be like a try read byte array, and we need the length of the array, and then this will return an actual byte array when it's done. Let's see, value equals new byte of length. We're going to copy to that value directly. Going to advance it by the length, and then just return true because we already have the value set. Okay, so now we've got this try read byte array, just to get rid of some of this duplication. So this is going to be if not sequence reader dot try read byte array, where this is going to be a GUID length out var bytes. There. So now I can copy this, and we're going to also do the same thing up in these other places where we've copied this. Now we have a length out var bytes, and then this just all goes away. And same thing up here when we're reading our other string. Short and long strings are now using those byte arrays. Okay, that's a little bit cleaner. Okay, like that. So now we have this try read GUID, and now we can actually finish off this. So out var request ID, return false. And now we can actually create a request ID and nickname, which is, well, that's interesting. It's not recognizing this not null when this must not work for. Oh no. Oh, I bet it doesn't work for because this is an actual nullable type. So for some reason it's not picking up on this this here. So I'll just give it a little help and say I know it's not null because that returns true. Oh right, it's actually a nullable type. So you gotta dot value into it. A little awkward, but that's fine. So now we're also reading the GUID on our ACK and NACK response types. And we can pass these in here, dot value. We know it's not null because it returns true. Okay, that works. That should. So Lars, talking about SQL, do you mean the multiple result set setting? I don't think that that's actually the same thing. There's like this weird thing that they have with multiple result sets. But I think that so what I'm talking about is the cannot I don't know why I can't asynchronous database multiple requests. Might be in here. So essentially the idea is, it's not in there. Okay. I don't know why I can't Google today. Multiple concurrent requests. Yes. All right. Yeah, I don't know why I can't Google this, but essentially there's a very, very common error. If you try to reuse this database connection, and I don't mean like reuse, I mean like if you're trying to use it simultaneously from multiple requests at the same time, like if you're doing a query, what people usually run into the problem with this is if they're doing something like entity framework and they in their dependency setup they configure their DB context to be a singleton. Actually, I wonder if I can do that. Search for that maybe. If they do it as a singleton instead of scoped, then they end up like trying to use that same database connection for all the time. And it ends up throwing an exception. Oh, I can't seem to find it. It ends up throwing an exception, which is really common, so I don't know why I can't find it. But essentially saying you cannot use a database, or no, there's already, I think it's already operation. No, okay, find it. But essentially, so the idea is it throws some kind of operation already. Yeah, here we go. Operation already in progress. That may be it. eventually give the error message. But anyway, I don't know why I can't find it. So it's a very common error. So when you have, it's not talking about like eventual consistency or anything like that. It's just the same connection can't be used to do two different queries at the same time. So that's what I'm talking about here. You want to allow that if you can. So okay, so we've got our serialization code, reading and writing those request IDs. Now we just need to update our actual application code. So in our chat client, this is just going to be, I'm just going to do a new GUID for now. And I'm going to say, I'm actually going to break this out here real quickly. And I'm going to say, just to do this in the logs, and this can just be message.nickname. All right, so just to have that request ID in the logs, and then the server side is, actually, while I'm in here, those ACKs and NACKs, I also want to say to dump in the logs. Oops. And NACK response message. All right. There, so now we're logging our request IDs everywhere on the client side, and then on the server side, this is a common pattern. So the side sending the request is the one that actually cares about what the request IDs are. The server side just reflects it. It's like, all right, I'm handling this request. I don't really care what the request ID is. I'm just going to reflect that in the response. So let's jump to where our errors are here. Yeah. So we've got our SetNickname request message. This is the message coming in, and it has the request ID on it. So we want our ACK and NACK to be for this request. So we just turn right around and reflect that back on the server side. That's the easy part. All right, that should build now. Okay, let's see where we're at. Should be logging these now. Let's turn off a couple of these. We'll connect, and I'm going to send my request message. So now I've got this blah, blah, blah. I've got an ACK for this same request. Now on the client side, I'm not like actually doing anything with this ACK yet, or NACK. We'll handle that in a minute. And then likewise, this one over here. So I'm not logging these out on the server side, but obviously they're being reflected back in the NACK and ACK messages. So then I got a NACK back, and then I can send a message here, and it shows up as Bob. Yeah, okay. So that's all we got. I just wanted to make sure those were getting reflected and serialized properly. So now. Now we have a request and response with an actual message identifier, and this is really what we want. So now I'm at a point where I'm going to check in again. Request IDs. Now I'm at a point where we can add an API that's even at a higher level. So what we have currently, again, is the pipeline socket, which is essentially a network stream. We've got our chat connection, which provides a stream of messages, right? There's not really a type equivalent to this in the .NET framework. But we've got our own stream of messages going back and forth with our chat connection. Now what I want to actually do is an API that's more like HTTP client. Okay, so when you call like HTTP client.get async or send, I think it's send async is like the general purpose one. That write doesn't actually complete when the write gets written to our local buffer. Right now, all of our writes complete like a socket write, right? So a socket write completes when it hits a local buffer. Our pipeline write completes when we write it to the pipeline, which is just like an additional buffer on top of the socket buffer, outgoing buffer. Our send message async completes when it gets into the channel, which is going to the pipeline, which is going to the socket buffer. So, so far we've patterned this after the writes complete when they get into the buffer, just like a socket does. Now at this point, when we want to do something a little higher level, like a send async or a get async, what we actually want to do is what we're really saying is I'm sending a command or a request, and I want to only complete this task, not when it's just written, but when I've actually gotten a response. And then you can also do things like include, any result data, or maybe there's an exception message. You can, like I'm not going to do that today, but you can take your general purpose NAC response and say, well, this also has a short string, or a long string, actually, more likely, that has an error message. Someone else has that nickname or whatever. So you can add that. It's not difficult to do, but what I'm going to focus on today is getting that higher level API, so that we can call from what we wanted to be able to do from our client is instead of saying, just having these ACKs and NACKs go wherever. What I actually want to do is to be able to say from here, to actually send, or to actually call like a SetNickname async, right? That's what I want. And then have that task complete when the response arrives. So much more like an HTTP client. So Freddie asks, could I talk about, there is no thread in the channel someday? Possibly. I don't know. It's a blog post that I wrote that is mainly just there to, when people start using async and await, a lot of times they think, well, it uses a thread, because that's, if you're coming from always having done synchronous code, that's just kind of a natural assumption that async must be using a thread. But in actuality, it's not. You don't need another thread to wait for a response. So like this, what we're actually going to do today is an example of that, where I'm going to write an API now that sends the nickname request message, and it's going to asynchronously wait for the response. Now the asynchronous waiting is not, there's no thread just sitting there waiting for the response to come in. Yeah. So let's go ahead and do that. I know I'm going like way over time today, but thank you all for staying with me. So let's see, what I want to do here, I'm going to push through. I want to get this done today. So I'm going to write up the API first. So what I want to do is, or what I actually want is a task, and this is going to be a task without a result type because there's no like actual result being returned from the ACK response. If there was, it would go here into whatever type goes there. And I'm going to call this SetNickname async. And here's my requested nickname. And what this is going to do, so I keep going back and forth, like, should this really be on this type or not? Because really this is like another level of abstraction. I'm so tempted to actually make another type here, but for now I'm just going to keep it in the same class. We'll see how ugly it gets. So what this is actually going to do is it's going to send a message. So let's go ahead and do that. So actually what I want is my SetNickname message, request message. And we're going to new up our GUID here and pass along the nickname. Now on the client side, okay, so and then we're going to send this message. All right. Now on the client side, this is where we want to keep track of what requests we have out there. Okay, so we're going to need something like probably concurrent dictionary. Yeah. Okay, so I'm just thinking here. Thinking out loud as we go. I'm going to call this a concurrent dictionary from GUID to just a task completion source. In the more general sense, sometimes what you want to end up with is like a more, a slightly richer type going in here. And the reason for that is if you have a connection and you've got like a certain number of outstanding requests on that connection, each one of those requests can sometimes have a bit of state to it. Like maybe you want, okay, so I can't think of a good example right now, but sometimes you want this to be a little richer of a type, you know, in a real world application. But for now, I'm just gonna say that's a task completion source. So in our SetNickname async, and actually I'm going to split this up just for clarity, because I don't want this to get too confusing. You can implement it just straight up, but there's certain assumptions that it's making, like, oh, well, all of the synchronous code in this async method is going to be run first. So I'm just going to actually split it up into two methods just to make it really obvious what's going on. You don't have to split this up. So this is going to actually be like, you know, yeah, I'm going to call it something horrible there. All right. So my send message async is actually going to go in here. I'm going to say, oh, you know what? This has to be newed up. Silly me. So in our concurrent dictionary, so what I want to do is create the request message, you know, get that GUID, create our task completion source, which we're going to use for completing this. Go ahead and do that. And when you don't have a return type, you can just use object. That's what I usually use. And then I'm going to, so this is all still in the synchronous part. The SetNickname async is returning a task, but it's actually a synchronous method. And it's only going to complete when that task completion source is completed. So this synchronous method, or sorry, the task returned from it is only going to complete with the task completion source. So the return, or so this method is called, and it's going to synchronously set up all of the state stuff that we need. Here's my request message, here's the GUID for it. I'm going to insert myself into this dictionary of outstanding requests, which I'm going to do right now. We don't actually need a triad. The triad will never fail because we just newed up a new GUID, so it can't possibly already be in there. And here's my completion. Oh, hey, I forgot about that. Task completion source now has a non-generic type. I'm in .NET 6. It's nice. All right. They added that a couple versions back. All right. So so the idea is that this is a synchronous method, and then we're going to actually return the tcs.task. So this when we're consuming it, it'll look like an asynchronous method, but really it's a synchronous method, and we're just setting up some state here, and we're adding ourselves into this outstanding request, and then we return this task saying this is going to complete when we complete this thing in the outstanding requests array, which we will get to in a moment. All right, so, oh wait, actually, my bad, because we actually have to send the message, of course, which can be asynchronous if we've got what's it called? Not backlog. If we've got back pressure going on, this can actually be asynchronous. So we're going to, yeah, so actually instead of returning the TCS task, I'm going to return do work. So this is the synchronous part of the work, and then the asynchronous part of the work is when we actually send the message and then asynchronously wait for the outstanding request to complete. Okay, so that works. Again, this do work, that's a horrible name, I apologize. But let's change that to send message and wait for a response. There. That'll work. All right, so this is actually setting up our state on the client side, saying, I have this outstanding request, and then we asynchronously send the request and asynchronously wait for that request to get a response. Now, we don't actually have the second half of this wired up yet, which we're going to do now. So because this is in the same type, I'm just going to keep it in the same type. We've got this SetNickname async, which now uses this outstanding request. So now our ACKs and NACKs are no longer going to be passed up to the application. We're going to handle those in this type as well. Just like we're handling the keep alive message, right? We're handling and ignoring the keep alive message in this type. Now we're also going to handle and ignore the ACKs and the NACKs. So where do we do that? Down here somewhere. Here we go. Ooh, this is actually in the parse messages. Yeah. We can handle that here, actually, when we're parsing. And that, let's see. Actually, I'm going to handle that up here instead. And I'm going to move that other handling up here too. Just because doing message handling in the parsing is kind of like, I don't really know about that. Okay. So I'm actually going to, I'm going to move this ignore code out of here and say it's complaining about our types because now this can be nullable. We don't actually parse out or we don't actually create an ACK or a keep alive message, but we could. I'm going to go ahead and do that. But just for consistency, right? So instead of returning null here, we're not going to be able to return null anymore. Oh wait, actually we do return null, but this is now going to become, what's it called? Not null when true. Right. So now we can come down here and say at some point down here, yes. And actually, this is very clever. The compiler is actually warning us, hey, you can't have this being null. Oh, that's right, but message is null for unrecognized messages. I forgot about that. Okay. So we still need to be able to return null here. My bad. So it'll still be null for unrecognized messages, but I want to add in a message type of 2 here. New keep alive message. So now we actually are going to get a keep alive message out of here. And this is just for consistency. I mean, it's actually rather inefficient to new up that thing, but I don't really care. All right, so where were we? So when we're parsing our messages now, this can be null still. So unknown message types are still null. I'm going to add that back in. All right. So this is where we're still stripping out unknown message types, and we end up with a list of messages. But now the difference is this also has keep alive messages. We're no longer ignoring keep alive messages here. They actually flow into up here, and up here is where I'm going to actually put in my special processing. This is where I want that to live. So we're reading from the pipeline. We parse out all those messages instead of just tossing them into our input channel for our application. I'm going to handle some of them especially here. So if the message is a keep alive message first, then we do nothing. We're just going to ignore that. All of our regular messages get handled up here. So I'm just going to say ignore. So now our application is still no longer getting keep alive messages. All right. But we are actually parsing them, just for consistency. And now I'm going to add in my other special handling here, which is going to be an ACK response message. Now in this case, what I want to do is I want to take a look at my outstanding requests. So Lars is saying he'd expect a task boolean to reflect ACK-NACK. I am planning to represent that as success or exception, where a NACK is actually like an exception. I can see doing it the other way. If you have if you have requests that have response data, like HTTP requests, right? Then it's more convenient to have that return type actually represent ACK response data. And if you have the NACKs have some kind of explanation or message, then that can be represented with an exception message. In fact, I might actually do that. I keep saying that, and I like that idea. But first, let's get this working. So what we want to do here is find our task completion source, and then we want to complete it. Yes, I'm smiling because I know the problem here. So if we have an ACK response message, we want to first find our outstanding request. It's going to be a try get value with that GUID. Actually, I wonder, I've never actually tried to, can we remove it? Try remove? But will it return? Oh, it does return the value. I like that. Okay. So we're going to try to remove it because this completes the request. We don't need it in our collection anymore. So I'm going to look for this request ID. I'm going to try to remove it. If it's not there, now we have to okay, so this. If you want to call this a protocol exception, then you can throw. So what essentially happened was the server sent us an ACK response for a request that we didn't make. Actually, I should do that. The server sent us an ACK response for a request we didn't send. So, really this is a protocol exception. You can throw here. You can also just ignore it if you want. I'm going to throw. All right. Okay, so now we have our outstanding request, or the task completion source for that. And what we want to do is say try set results. Oh, I don't have to pass null because we don't have the object anymore. Okay, so So this will set the result on, it'll complete that task completion source. It'll complete that, which then ends up completing the do work. No, it's not called do work anymore. The send message and wait for response async. It'll end up completing this task, which then completes the task returned from this, which is also the task returned from this. So now we have a SetNickname async that returns a task that completes when the response gets in. Okay. We haven't handled the knack situation yet, so let's go ahead and do that. There we go. And it's going to be very, very similar. Again, some protocols have like just like a response message type, and one of the fields in there is whether it's ACK or NACK, because a lot of this kind of handling is similar between the two. So again, we try to find our outstanding request. If it's not in there, then it's a protocol violation, and in this case we want to say try set exception, and we're going to say I'm just going to do this this way. And we can say request was rejected. I don't actually have an error message in here yet, so that's really all we can say about that. Just like a generic, hey, your request was rejected. All right, so that should handle this. There's one other thing that I want to point out, and this is because this isn't very obvious at all. But what actually happens is this try set result here. So we've got our own async void method here. It's running. Actually, this might be running on the UI thread on a client app. I don't think we ever actually explicitly use a task.run anywhere in there. But anyway, this is running in whatever context, and this try set result actually completes its task synchronously, and the task actually synchronously runs all of its continuations, which includes this code up here. So what you can end up with is this kind of an awkward stack situation where you've got this code like in the middle of your processing loop where you're copying stuff out, and you want this code to be like continue running independently. Instead, it's actually going to call. This code is actually going to call into the state machine for this code, which is then going to call into the state machine for whatever calls this, and you're ending up running application code inside of here, which you don't want, right? You want your loop just focused on this. You don't want your application code running inside of this call. So this is what happens by default, and this is one of the corner cases of async in a way that's I don't want to say dangerous, but it's something you have to keep in mind. So in our case, there's a very easy way to avoid it, and that is when we new up our task completion source, there's a flag you can pass task creation options. And it's task creation options dot, well, actually, you want some of these. You want deny child attach anyway, but the real one that you want is run continuations asynchronously. It's the very last one in the pop-up list there. This is the one that you really want to have set. And all that does is instead of running the continuations in line like it normally does, it says any continuations for this task, which includes like returning from this method, will actually be run on a thread pool thread. It just gets kicked off onto the thread pool. And then the application can do whatever it wants there. It'll await this task in, and on the client side, it'll jump back to the UI thread. So, okay, no more questions in the chat. Let's use this. I think that this will work. Let's compile first, and I'm pretty sure this will work. We'll see. So let's use this in the chat client. So now we have this SetNickname async, which is more at the abstraction of like an HTTP client.get async, right? This is something that actually doesn't complete until that round trip to the server. So So what we're actually going to end up doing here is saying, I want to do, okay, so if we have a connection, this is going to be in a try-catch because it can be knacked, and that's fine. But I'm going to say, I'm going to first log saying, sending my nickname request. And then I'm going to await my chat connection dot set nickname async. So this is a higher level API than just sending a message. And I'm going to pass in my nickname text box dot nickname, which is the one that I want, which is not correct. Nickname text box dot text, which is the name that I want. All right, and then we have success and failure. Okay, so the success just comes in right after this. Now, there is something that you have to be aware of here, at least in GUI applications. With this await, anything can happen in here, right? User interaction, blah, 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 whatever. So it is entirely possible that you sent the nickname request for this, and then, you know, this all happens. This all happens synchronously before the await. This here, reading this nickname text box dot text happens synchronously. It calls set nickname async, and then it awaits it. So this is all fine. But then after this await, it is possible that the nickname text box actually has different text. So in order to make this log message actually correct, I'm going to copy this out into a separate local variable. Just one of those quirks you have to be aware of with when using await with GUI applications. Anytime there's that await, anything can change on your GUI. You know, things can be enabled and disabled, and state can change, and your text can change, and all that. So, I'm just going to say nickname. And by pulling this out and reading it once into a local variable, I avoid that problem. So now my log text is going to be correct, even if I'm super fast and change it in the UI. And I'm just going to log on errors, unable to set nickname to nickname, which should be pulled out a level higher. And I'm just going to say, here's my message for that. All right. So now this is what this looks like on the client side, and the other thing that we can do is get rid of all of our ACK and NACK messages, because we don't need to handle those on the application level anymore. Those are handled inside of our chat client, or chat connection type. So I like this because now our application is really only dealing with application concerns. It handles the broadcast message. It sets this nickname asynchronously. So it is a nicer, higher level API for the application here. On the server side, doesn't really change because, yeah, it's not the one sending the message, sending the requests. If our server side also sent requests, we would want to do something similar on the server side. So okay, so I built. Let's test this out, see if it works. Hopefully it works. All right. So now we've got our chat clients coming up. Let's connect up here, and we can send messages back and forth using our IPs. I'm going to set my nickname to Bob, and it says sending nickname request for Bob, successfully set nickname to Bob. I'm running on localhost, so there wasn't a lot of time for me to change the Bob text, but technically it's possible. Going to do the same thing over here. Sending nickname request for Bob, unable to set nickname to Bob, request was rejected. And this was just, the generic error message that because we have a NACK without any additional information. So now if I send over here, This one comes in from Bob. And I can send over here and it's still coming in from the IP address. All right, so that actually all worked very nicely. All right, excellent. So there is, just real quickly, I want to do one other thing. And that is add an actual error message to our NAC. This is very common. I'm just going to say message. A long string explaining why the request was rejected. This is just going to be a, should be a pretty quick change here. Actually, I'm going to check these in first. So now we have our higher level API, yeah, which was the main thing I wanted to show today, which is why I kept going along. So I'm just going to add an error message to this. And this does change all of our serialization for the NAC message. So first the length. If it's ACK message or NAC message, and now these are different lengths. All right. So that nice little or is now completely gone. Oh well. So now instead of just a GUID, it also has an actual long message with that. So we've got the plus the GUID length plus long string field length of the NAC response message dot message. Kind of overloading message there, but that's common. All right, so that handles determining the length. Let's jump down to where we're writing it. Now we write the GUID, and then we write the long string of the NAC response message dot message. And now let's jump up to where we're reading it. And we handle, but the one thing about, I don't like the else if, but I really like having all the serialization in one file, both reading and writing. So we read the GUID, we read the long string, and then we create the new NAC message. There. That's, and I messed up my parameter order. And I can't use the message, right? Okay, so this is going to be message field. Oh well. So that's the problem when you overload words too much. All right, so I'm reading into a message field. And so that should handle the serialization for a new NAC message. Let's go ahead and build this and it'll fail. Actually, I want to handle the client side first. So now when when we are in our chat connection and we're reading out a NAC message and we're handling that, what I want to do is actually pass this in. Instead of this generic error message of request was rejected, I'm going to say my NAC response message is going to be, or is going to contain that error message. All right, so now we can actually return an error message from the server. So let's do that. In our server, I'm going to say, well, okay, so it's still going to be kind of generic. I can change this to say like, well, this other IP has this nickname, but I'm just going to say nickname was already taken. And of course, I'm messing up my argument order again. All right, there. That should do her. So now this is just a slightly nicer nicer little tweak to our protocol here, so that when we have two chat clients and they're both connected, one of them gets, the first one to request it gets it, the other one now gets this error message back from the server, which is nickname already taken. And this was actually returned by our server back as part of that NAC message. All right, so I am pretty pleased with where we ended up here. Okay, yeah, we'll call that good. So what we did today, the main thing that we did was just put in some helper code in order to create this SetNickname async, which is this higher level API. And I kind of tossed back and forth, oh, maybe this chat connection should be like, maybe we should have like another higher level type on top of that. But with a chat API, a lot of times you're just sending messages anyway. So you've got that send the broadcast message, send the chat message. That's most of what you're doing anyway. There's not a whole lot of request response. Now there's other things that we can do to add that kind of thing if we wanted. But this is the main thing I wanted to get done today, was show here's how we can keep track of outstanding requests on the client side, or actually on either side. Because this is in the chat connection, we can actually have requests from the server to the client just as easily. We can add that just as easily. We just happen to be only using it on the client side. But we have that outstanding requests collection, that concurrent dictionary, and that has a task completion source in it. So Freddie asks, what if we never get an ACK or a NAC? Very good question. So I'm not handling that situation in this. There are some things that I'm not handling, and that is one of them. So maybe we have like a certain kind of expectation of I have to have a request in a certain amount of time kind of thing. Because right now, our protocol is very open. We just say, well, I'm doing a request, and eventually a response will come back. And depending on the protocol, maybe that's what you want, maybe that's what you don't. Now, the protocol, I would say if the protocol itself defines you have to have a response with, the server has to respond within 10 seconds or something, for a nickname request. In that case, then I would say you could go ahead and put the timeout in here. Otherwise, I would say that's really more of an application level concern, and it would more properly belong over here. And in this case, you can say SetNickname async dot wait async is a new method in one of the more recent versions of .NET. I have an async EX library, and I define a wait async extension method that does practically the same thing. So you can actually pass a timeout here, either via cancellation token or a time span. So you can say, well, it's got to respond within 5 seconds or something, right? And then this will actually throw an exception if it doesn't. Now, if it doesn't, just to be clear, on the client side, you want to be careful doing this kind of thing, because as far as your chat connection is concerned, it still has that outstanding request. And that is still going to live in that collection. And really that's what you want, because on the protocol level, that's still an outstanding request. You don't want to time that out unless the protocol actually specifies timeouts. So as an application level concern, you want to interpret this wait async failure, which would be I'm not sure if this would actually throw a timeout exception or it is a timeout exception, okay. So in that case, you'd want to actually say like catch timeout exception, and like throw it, or that would still get caught into the, what you'd actually want to do is something like this. Something like this, where So you'd want to be careful with your error handling. Right now, oh, if it's an exception, then fine. We're just unable to set it. But if we have a timeout exception, and we actually would want a timeout exception here. In this case, I'm going to say that this is a violation of the protocol that I want from the client side. So the proper thing to do is actually to completely close my connection, right? So I would just say chat connection dot. What do we have? I guess we have complete. Is the only way I gave to close that. That's fine. So we would actually completely close this, set it to null, whatever, and just dispose of my chat connection completely. If you don't respond in the amount of time, I still have some state in my chat connection that is waiting for that response. So those are the couple of ways to handle that. I would usually not worry about timeouts, and the server just responds whenever it responds. At least at this level, because HTTP client.timeout causes a lot of problems, to be honest. It's confusing. People end up using poly anyway. In a real world application, I would say the application should be using something like poly, or at the very least this kind of wait async thing. But then treating the connection as though it's no longer viable if the server doesn't behave the way you want it to behave. That's the approach that I would take. Okay, so I'm just going to delete this because that was just used for talking and not as an example. All right, so okay, so that concludes day 11, which was a full 2 hours. Apologize for that. But I think this might be the last time I'm actually in the code. I'm going to do one more day for sure. Just as a summary of what we've done, a lot of things that we didn't do that you might want to consider. And also taking a look at a good number of tools for when TCP/IP applications aren't behaving the way you think they should. I've already shown some of them along the way here, but I'm going to be going in depth with some of those tools. And yeah, so tune in probably Monday morning for the last session. Probably the last session, maybe, unless you guys talk me into doing something else. So now we've got this higher level API. I'm very pleased with it, with where we ended up today. And thank you all for coming. We'll see you later.